Welcome, everyone. This is the Carbon Leadership Forum LA Hub webinar. We try to host events, either in-person happy hours or webinars like this to have open dialogue with the community around topics pertaining to embodied carbon. And I'm super excited to welcome Jonathan and Mikaela today, two friend colleagues of mine who I'm sure many folks probably also know them, but kind of pillars in the embodied carbon world, both having studied or done research at college. I'll just kind of introduce Jonathan. I know very well through SE 2050 activities. He's part of the data science team and did his PhD at Will Strubar's lab at CU Boulder, and now has made his way to MIT and has a recent position there in the last year. Tons of research. I have to say, Jonathan's, I'm always amazed at the breadth of work that you do, Jonathan, just general research. And then Mikaela DeRousseau, also really a great kind of researcher in the field, had previously worked at Building Transparency and EC3, which I'm sure most folks are familiar with, and now has her own LCA consulting firm. And they're going to share some research that they've done specific to concrete EPDs, and excited to learn more from them and then kind of have a discussion as a group too.
Great. Thanks for that, Luke. I think I'll start off here. Thanks for the introduction. And we're going to be talking about a study that investigated a data set of ready-mix concrete EPDs and the trends in that data set related to global warming potential impact of mixes compared to kind of looking at reported application in those mixes. And so this study was led by Jonathan, and I provided some support. It's currently in review with a journal for publication, and I'm just going to provide an introduction to the topic, and Jonathan's going to dive into details of the study. So I'm just going to start off at the 30,000 foot level here. So cement production is a highly impactful material related to greenhouse gas emissions. It's responsible for approximately 8% of global GHG emissions. And as we know, cement is a critical component of ready-mix concrete and is oftentimes on the order of about 90% of its impact related to greenhouse gas emissions. And then the reason I'm talking at the cement level is because it's a big contributor, but also because it's a difficult piece of the pie to decarbonize for basically two reasons. Process emissions, which you're probably familiar with, coming from the actual chemical reaction that happens during production of cement called calcination. And then it's also difficult to decarbonize because of basically the fact that we're using a lot of fossil fuels at high temperature in a kiln, and this, in kind of a traditional clinker production sense, is hard to change that process. So you can't really easily electrify it or something like that. So that's kind of the problem we're looking at, and just terms you should be familiar with, and I'm sure are, but we'll say it anyway. Global warming potential, or GWP, is the metric used to describe the climate change impact of a product. And then embodied carbon is often also used, and it's specifically used to refer to the GWP, or climate impact, specifically associated with raw material extraction, transportation, and manufacturing for a product. So isolated to that scope, basically. Yeah, so getting to kind of more of the disclosure and reporting aspects of embodied carbon and global warming potential. One of the main tools, as you know, for disclosure used at the product level are environmental product declarations, or EPDs. EPDs are used to report the environmental impacts, including GWP, but also other environmental impacts that are important of construction products like ready-mix concrete. And in North America, these EPDs are reported with a cradle-to-gate, what's called a cradle-to-gate scope. So this simply means that what's reported on an EPD is impacts associated with raw materials, extraction and supply, transportation of those raw materials to the site, and then manufacturing impacts at an actual facility. And that's what's known by the manufacturer and reported in the EPD. This is distinct from other reporting under other standards, such as those occurring in Europe. So, which is good to know. The declared unit, so the quantity of material reported the impacts associated with a certain quantity of material is called the declared unit. And for ready mixed concrete, that's 1 cubic meter. And then the reporting and LCA methodology requirements in mass are set by the ready mixed concrete product category rules, or PCR, as well as kind of a set of cascading ISO standards above it. So that's just good to know about EPDs and how the rules are set. Many folks are aware of how valuable I think EPDs are related to understanding and getting a grasp on global warming potential impact for a product. So they'll take a look at an EPD, look specifically at the GWP value, and maybe make an assessment and say, okay, I know this product has this impact, etc. But I think it's valuable to point out that EPDs contain a large amount of valuable information, especially kind of in aggregate, I would say. And the product category rules are standardized for materials like ready mixed concrete. And so it is required by those rules that, the manufacturer name be published on the EPD. For example, the plant name and location have to be published on the EPD as well. The date of issue has to be there. And then, things like performance information, specifically the compressive strength at a certain curing time, has to be reported on the EPD. Even product components have to be listed. So this is good because it's standardized, and we can count on EPDs all having this information. And then in from a data set nerd perspective, there's a lot you can do once you have all that information extracted from PDFs. So I'm just kind of alluding to the work here. And then I'll just touch on kind of the uses of EPDs, why they're quite useful, and I think that the use cases are evolving and growing over time. I think originally the use cases were disclosure, right? And we're really seeing a growth in kind of imagination of not imagination, just people seeing the value of EPDs. And so, manufacturers, for example, can use EPDs to understand the drivers of impact, and this can lead to reductions or even just isolating, okay, we know this is where the majority of the impact's coming, let's focus on that. But other use cases they can be used to kind of communicate and trace impacts across a complex value chain. AEC stakeholders can, be provided EPDs to understand the impact of materials that are getting purchased. And then even over time, this can kind of lead to more decision-making actions. So trying to reduce embodied carbon over time. And then they're even kind of being used to support and provide information related to public policy. And so I think like I said, we're really seeing the growth in the use cases of EPDs. And so Jonathan and I kind of brainstormed this slide of like, what is the current state? And we want to give a lot of props because I think that ready mixed concrete is definitely the most advanced in the EPD space, right? Like there's tens of thousands of ready mixed concrete EPDs published for North America. They're the only construction material anywhere near this like level of coverage and disclosure. And then we also want to acknowledge that, so there's certain metro areas where you're like, there are thousands of EPDs in this one area representing the mixes that exist. But then there's also other pockets that have quite limited representation. So yeah, it's an interesting place. And we were brainstorming this graphic of like, we think that we're at this sub peak right now. And then we think that there's also room to grow basically of quantities, but also quality and information that can be included on EPDs that would serve a large value. So other current state information is that the new version of the PCR is really at the finish line, which is great news. And like I alluded to a second ago, we think that kind of comparability and performance information reporting, because of the use cases that we're seeing for EPDs, will continue to be and grow in value given the new ways that EPDs are being used. And next slide. Last thing is kind of just moving into the actual study content is related to performance information. Application reporting is kind of a prime example, right? I'm getting at this because ready mixed concrete encompasses a huge scope of application types. It is not a single thing by any means, as shown by the photos on the left. And so just because you have ready-mix concrete does not mean you have a certain type of material. And just because you have a certain strength of concrete doesn't mean you know what you have. So it's applications currently not mandatory in the current PCR. However, sometimes application descriptions are reported in the product description field for ready-mix concrete EPDs. And a little example is provided below with the external wall wording here. Basically, it's a free-form field in EPDs, right? You could, a manufacturer can put application there if they'd like to. It can be whatever format and nomenclature can be used. And so kind of the jumping off point for this study was, can we, learn anything when significant numbers of EPDs are reporting something related to application in this field, in this box? And we wanted to take a stab at what kind of application is already being reported and various trends in the data related to that. So I'll pass it over to Jonathan to take it from there.
Awesome. Thanks, Mikaela. That was a great introduction to this work. So to kind of get at that question that Mikaela was just proposing, we wanted to use a ready-mix concrete EPD data set, specifically one that I've curated over time, that I've made and I guess developed. And that was because I collected a lot of different ready-mix concretes EPDs from ASTM, off of their website, from NRMCA. And then I wrote a custom Python script to extract key information from EPDs. Like Mikaela said, a lot of these EPDs are in PDFs, so I used a scraper to get information, including the compressive strength, mixture description, the GWP, specifically the A1 to A3, global warming potential, the product components, plant location, and a lot of other information. And I, again, took all this information to populate this CSV file or this Excel spreadsheets. Currently, it contains over 47,000 unique ready-mix concrete EPDs that are based in the United States. They don't have any EPDs that are currently manufactured in Canada or again, places outside of the US. So I do have a link for this. I'll share this at the end of the talk, but this is something you can download and look at today. So I originally made this EPD data set. Really, I started at the end of 2023. I published an open access paper kind of explaining some of the fields and information that I was gathering from the EPDs. And then over time, I've been updating this data set. So as you can kind of see, the most recent update happened this past December, which has a lot of the different fields, like the intended application, or what we're kind of perceiving as the intended application from the different concrete mixtures in this data set. So like Mikaela said, this isn't obviously across all EPDs, but there are many EPDs that provide keywords in their mixture description label. So one of the things that we did at the start of this study was to just do a frequency analysis. What words are frequently coming up in the mixture description of these EPDs? And we found a number of different keywords associated with the use and intended application of these concrete mixtures. As you can kind of see here, like exterior, interior shotcrete, and so on. So many different keywords that we could start to kind of identify key applications based off of these keywords that we were finding. So that led us straight to, I guess, identifying 5 primary applications of concrete. And those are a structural application, hardscape, paving, infrastructure, and lastly, filler. So these were kind of the 5 different primary applications, again, from what we were kind of seeing in that keyword analysis. Some of these application categories were further classified or categorized into subcategories. Looking specifically at structure, for example, there were a number of subcategories, including foundations and footings, slab and grade, an elevated horizontal, wall, column. So again, especially for some of us LCA practitioners on this call, if you start to think about the different elements and components in your building, or even different projects that we use concrete for, there are many different elements here. And we can start to see, again, just these different subgroups or subcategories based on a primary application. And then again, from that keyword analysis, I associated these keywords to subcategories, which of course were tied into the primary application categories as well. So these keywords were used to categorize the EPDs, again, based off of the keywords in the mixture description provided in the EPDs. Additionally, there were 5 other application labels, and that's because these were some of the most frequently found keywords in the keyword frequency analysis, especially exterior and interior, but we also saw a lot of commercial or residential or those keywords being pretty prominent, in addition to lightweight concretes. And the study did look at the GWP distributions and statistical analyses for these other application labels. But generally they were, I think, most helpful to further categorize the primary applications. Like, for example, you might have, to the example that Mikaela showed, like an exterior wall, for example. So there's lots of different ways, or like a residential footing was also pretty prominent, that combination as well. So these were, again, all the different application labels and categories that we were defining in our study. Furthermore, we wanted to make sure that our specific subset of EPDs that we were looking at in our study were close to apples. So I started with, again, north of 47,000 EPDs that I was looking at. I wanted to filter them to make sure they all had the same cure time of 28 days. Of course, you could look at other cure times as well, but as you can see, at least in my data sets, only about 2,500 of those EPDs specify something that's not 28 days or a 28-day cure time. I also wanted to look at a specific strength range, which I looked at 6 different bins, but I basically filtered out anything above a compressive strength of 8,000 PSI, which again only excluded 266. So again, most of the EPDs were within that strength range. And then after applying those different keywords associated with those different applications, I had different sets of EPDs corresponding to applications, and then some, of course, that don't have an application associated with it, again, based off what's provided in the mixture description. So we ended up having 10,766 EPDs that were associated with one of those keywords attributed to an application. So I'll quickly pause here just to kind of get you guys thinking on this call. I won't do a show of hands or anything, but think to yourself for a second. Which of these 5 primary applications do you think had the largest representation out of those 10,000 plus EPDs? Structure, hardscape, paving, infrastructure, filler. Give you 3 seconds to think. Would it surprise you if I said that filler had the highest representation out of those 5 primary applications? And I extended this to the 5 other applications as well, but it had by far the largest representation out of the EPDs that we were analyzing, which surprised us pretty significantly. One of the other key findings was that roughly 70% of the EPDs that were associated with an application were in these 2 different strength class ranges. So between 3,001 to 4,000 PSI, and then 4,001 to 5,000 PSI. So for the remainder of this presentation, I'll just be sharing the results for those 2 different strength classes. But we did do the analysis for all of these other strength class ranges as well. So to kind of help orient us, I'm looking at first, the 3 different EPD sets, the filtered EPDs, the non-application EPDs, and then the application EPDs for a compressive strength of 3,001 to 4,000 PSI. And you see global warming potential, that's the A1 to A3 GWP on the x-axis. And you can see, by the looks of it, the application EPDs have a similar distribution, like for GWP, compared to the non-application EPDs and the filtered EPDs. So that includes both sets. When I break this down into those 5 primary applications, we can see that there are differences, and it's visually clear. Fillers had a pretty high GWP, or trended with higher GWP compared to these other 5 applications, or other 4 applications. Paving and structure, on the other hand, trended with lower GWPs, which is quite interesting. And if you actually think about where that median is for the structure subset, roughly 290 or GWP around 290, That's about at that like 25th percentile when you just consider all filtered EPDs. So we found that pretty interesting. When we looked at the 4,001 to 5,000 PSI strength range, we similarly found that application hierarchy where the EPDs associated with a filler application trended higher, then hardscape, then infrastructure, then paving, and then structure, although those two are pretty close. Actually, paving might even be a little ahead. But both of those trended a bit lower. So we thought these studies, or we thought these findings were really interesting. They were frankly surprising to us. So we wanted to kind of confirm what we were seeing visually in these box and whisker plots to what we would attain if we performed some statistical tests. So we performed two different statistical tests to basically pair up the applications to one another to confirm or reject the idea that they have statistically different global warming potentials. And the two statistical tests were the Koch-Smirnov test, the KS test, and the Mann-Whitney-Hughes test. So the KS test kind of basically tests the similarity of the box and whisker itself, the distribution of the GWPs between application pairings. The Mann-Whitney-Hughes, for our case, more or less was kind of seeing if there's a statistically similar median GWP within that distribution. So two different statistical tests, but they kind of point to the same thing. In our study, we were saying if the pairing, the application pairing, like filler and structure, for example, had a p-value that was below 0.05, then there would be proof that they would have statistically different global warming potentials. So this is just kind of a heat map showing those results. As you can probably quickly see, there's a lot of white and a lot of light blue, which means that there's a lot of statistically different global warming potentials across these different application pairings. So again, 85% of these pairings had statistically different GWPs. The only ones that kind of didn't was the pairing between infrastructure and hardscape, which was kind of interesting for both strength classes, and then structure and paving for the Mann-Whitney-Hughes. So again, now we're not only do we have the visual observation that there are GWP differences, now we have statistical knowledge that there are statistically different GWPs here. So why do these differences exist? We kind of were thinking about this, and I think the most obvious example or obvious explanation really was something that Mikaela alluded to at the start. Cement drives the GWP of concrete mixtures. So certain concrete applications just have more cement than others. Some like fillers, like cement grouts, shotcrete, likely have more cement content, so they're going to trend with higher GWPs. That's intuitive. The challenge that we couldn't do is we don't know the mixture proportions of all of these different concrete mixtures. So we can't confirm that, although we have high suspicion that cement obviously is going to be driving a lot of these differences in GWPs. We also thought about three other ways that we could explore these differences using the information that we extracted from EPDs. So we looked at the use of supplementary cementitious materials, or SCMs, that were reported in those product components that Mikaela referenced early on. We also looked at the type of cements, really if the concrete mixture was specifying OPC or ordinary Portland cement versus like PLC, Portland limestone cements. And then we also looked at the type of Portland cement data. What was the LCI source that was used? So we did some pretty deep dives into this, and I don't want to spend a ton of time on each one, but I'll kind of share the highlights of each one of these different findings. Going first to SEM analysis, we found, which makes sense, when concrete mixtures report the use of SEMs, they generally have lower global warming potential. The more nuanced finding was that they don't always translate to lower GWP when you look at the different applications. So what I mean by that is, like, if you look at just the three EPD sets, which are at the top half of these box and whisker plots, for both strength classes, the use of SCMs clearly, like 50 to 20% lower GWP, again, for both strength classes. And just to help orient ourselves, these dark blue boxes are the concrete mixture that don't report SCMs, while the lighter blue do report the use of SCMs. So again, that makes sense when just looking across these different large data sets. However, when we break it down for the different applications, especially from the 4,001 to 5,000 PSI strength class range, we see some nuances. One of the nuances that really surprised us was for hardscape. The hardscape EPDs that didn't use an SEM have much lower GWP than those that did report an SEM. And I know these numbers here report like those are the number of EPDs associated with a hardscape that didn't or did report an SEM. So those are low. I would imagine that those probably are more similar than not, or that the mixtures that do use an SEM probably would be lower. But something else that caught our eye too was if you look down at the structure at the bottom here, there's 167 EPDs that do report the use of an SEM in a structure application, and they have roughly the same median GWP. So kind of interesting, right? So I think, again, the use of SEMs often does, again, translate to a lower GWP, but not always, which is kind of fascinating. So there's more nuance. The SEM analysis doesn't fully explain the differences here. Looking at the different types of cements, we found across the board, consistent for the EPD data sets and for the primary applications, those concrete mixtures that reported the use of PLC compared to OPC often had 10 to 50% less global warming potential. So that's pretty well backed by many different scientific studies. We're clearly showing that across the board and across all different applications here. Something to note, there were definitely less EPDs, less application EPDs that did use PLC compared to OPC. If you noted, I kind of breezed over this looking at the SCMs. Many application EPDs, 3,000 out of the 4,700 EPDs for the 3,001 to 4,000 PSI strength range did report the use of an SEM, similar, a large amount for the 4,001 to 5,000 PSI strength range. We don't see that same large use of PLC in the EPDs. We see much lower, maybe like a quarter-ish to a third of the application EPDs using PLC. So PLC does obviously indicate that, or the use of PLC does indicate lower GWPs, but there isn't one application that is definitely using PLC. I mean, you can kind of see here, fillers, there are about 10% of EPDs that do, a little bit more when you consider the 4,001 to 5,000 PSI strength range. Paving, a lot of paving EPDs in our analysis did use PLC compared to OPC, which we found was interesting, and then a number of structural EPDs too. But again, there's no clear distinction that there are EPDs or applications that definitely do or don't use PLC, except for maybe infrastructure. So that was another interesting finding. And then lastly, we wanted to kind of compare the concrete mixture GWPs based on the type of LCI data that they reported for Portland cement. So this is not Portland limestone cement, this is just Portland cement. And we were just comparing those EPDs that reported either supplier-specific information or supplier-specific LCI data, or used an industry average EPD data. And you can see, again, these results are pretty consistent, but we found that roughly using supplier-specific LCI data reduced the GWP by about 7 to 10% here. It was interesting. Several of the different applications had almost the same median GWP, looking at filler across both of the different strength class ranges, hardscape in the 3,001 to 4,000 strength range, even similar for like paving, and then structure for 4,001 to 5,000 PSI. So again, none of these different like sub-analyses fully explained the differences in the application GWPs. So truly what we're kind of thinking then is there are differences likely just due to the inherent differences in the mixtures for these different application types. All right, so let's put a bow on this. So like we've been kind of saying now, there are statistically different GWPs when you look at the 5 different applications. Cool. So what does that mean? Really, what we're proposing is that the product category rule, or the PCR for ready-mix concrete, should be revised in the future to include the specification of an application reporting field, at least for these different like primary applications. That's just because we want to enable more fair comparisons between EPDs. It doesn't make sense if you're comparing a ready-mix concrete EPD that has a filler application to one that has a structural application like a foundation. As we have shown in our study, there's a huge GWP disparity between the two different applications. So, yeah, paving is structured statistically trended with lower GWPs. I mentioned filler trends with higher GWPs. So for those LCA practitioners and sustainability consultants on the call, your whole building LCA, whole building LCAs that rely on application agnostic GWPs could actually lead to larger or inflated GWPs if you're not thinking about the different applications. Lastly, the use of SEMs, using Portland limestone cement type 1L, the use or reporting of supplier-specific LCI data can partially explain the GWP differences, but not completely explain these differences. So for people who are looking at using and procuring ready-mix concrete EPDs, like definitely look for these characteristics, because even if they don't fully explain why we're seeing the differences of the application GWPs in our study, these are clear indicators that meaning the concrete mixtures, have lower GWP than others. So again, for those on the call, look for those characteristics when you're actually trying to reduce and minimize your GWP. So I definitely want to thank Mikaela, who's my co-moderator, for helping me on this study. I also want to acknowledge JP Jevanon at Penn State and Professor Will Strubar at the University of Colorado Boulder for their help and advisements on this work. I definitely thank Luke and Rochelle and the whole CLF Los Angeles team for giving us this opportunity. Luke's known about this work for a while, so it's nice to finally be able to share it with a broader, bigger audience. So thank you guys for giving us that chance. And thank you guys for listening. Would love to get to your questions in the chat that I'm seeing pop up. And then on the right here are 2 QR codes, one for the preprint of the paper. It's in review, but we have a preprint that's like freely open access available. You can download it. And then the data set that I mentioned as well, you can take a screenshot or a picture of that QR code to access that. Thanks.
Well, round of virtual applause. Thanks so much, Jonathan and Mikaela. Personally, I just think it is a really fascinating topic and one to come to with a lot of curiosity. And I'd say upfront, like, thank you for doing this work and especially being so transparent and like sharing this openly, giving a presentation of this group and opening it up for discussion here. Concrete is one of the things I would just note that, like, as a practitioner, we put a lot on as a reduction. And so I do think it's important for us to kind of be aware of where those numbers are coming from. And I think this is a very nice diagram of like taking what we have now today and obviously building on that and continuing to improve. We have just a couple questions in the chat, and I'm sure it'll lead to more discussion. The first question from Tara, just a very pragmatic question: what applications would be included in paving versus hardscape?
Great question. Let me see if I can jump to. It's not letting me do it. There we go. I had some pre-populated questions, but I'm going to jump to this here because I wondered if there would be a question like this coming up. So pavement and hardscape, they are very similar. As you can kind of see, this is the table that we had in the paper, so I apologize. It's not in a neat visual diagram, but hardscape, you can kind of see it's more like the curved sidewalks, barriers, while paving is more like the DOT, like paving that you would use for roads and transportation.
Great to see this too. I think it really helps kind of give some context or how it's sorted, and very interesting kind of engine that you've used to kind of make this analysis. The other question was from Nathan. I think, Mikaela, you answered it regarding reporting versus not reporting SCMs on slide 27. Does this imply that did not report EPDs don't have SCMs, or just that they did not represent or did not present the EPD? Any context you want to add to that, Mikaela? Or
I don't think so. I think just if did not report isn't clear, it just means that the mix didn't have any information related to SEMs on it. So we can safely assume that as long as it's reporting right, it didn't contain any SEM.
Great. So then I'll also kind of seed some conversation here with a question that I've wondered a lot, and I'm sure I also note that there's lots of folks who are very knowledgeable on this topic and potentially even on the concrete PCR committee. My main question from this is, why don't we include application? And it's my understanding that in the next version, so PCRs are updated, correct me if I'm wrong, every 5 years. The next round of PCRs will also not include application. And it's something that fundamentally to me, I feel like if we put so much on this, it's a pretty foundational question, and pun intended. It's like if we're thinking about concrete foundations and comparing those to like PT slabs, those seem very not functionally equivalent, right? And we even recognize that in some applications where we increase the limits for things like PT or early strength required. So it's a big question, and I appreciate it can be kind of a spicy topic, so I appreciate everyone having respectful conversation. But I'm just curious, as a group, what do we think about that?
This is Tiffany. Mikaela's on the committee. So I'm the chair of the concrete PCR committee, and we are coming to the close of the updated version. And I think that it was a long, drawn out process to get this PCR over the finish line. And producers and some non-producers did not vote to pass the mandatory requirement of including application. It is in future business and will be included on the next version of the PCR, which we are targeting to be a whole life cycle PCR, where you'll have to report your application there. Basically, it was just too hard. The argument against was too much change too quickly with the current PCR going through revision, and already onus is on producers to give a lot of more granular information on this upcoming version of the PCR, and they had proprietary trade concerns. One of them was just trade concerns about being able to back calculate mix designs and giving out, competitive proprietary information that they weren't comfortable with. And another one is really hard to track exactly where the concrete is being delivered. It could be in more than one spot on the project, the same strength. So that was why it didn't pass. And we had advocates on both sides, so we had a lengthy discussion about it. And it was decided to put in future business as we go through a whole life cycle PCR for concrete products.
Mikaela or Jonathan, anything else you want to add to that? Thanks, Tiffany.
I think it's a good summary, Tiffany. I think I've sat in a lot of PCR committees, and it is I would say a fascinating stakeholder experience to learn the variety of perspectives of different stakeholders. And I also have learned that there are trade-offs. As a person who is a proponent of disclosure, generally, I understand that there are trade-offs in cost and time to every additional field that we elect to add as a requirement. I'm a proponent of reporting application, but I also respect the position that there are plenty of people on the PCR committee who didn't think it was valuable enough, even if that's not my position. So I think that's probably the balance that Tiffany is referring to.
And Brandon had a comment.
Yeah, Brandon, you want to chime in?
One, I think our industry is highly, I have personally always advocated for exactly what we're seeing right here, like a shotcrete mix, for instance, obviously has a very high carbon intensity, but it's also because of the nature of how the mix is batched and delivered and installed. And so, a sidewalk or something that comes down the chute for a driveway for 4,000 PSI is much different than a 4,000 PSI we're pumping 10 stories into the air. So we obviously want to get that granular to be as specific as possible, but the reality of the situation, I've worked for a producer, Central Concrete, for many years, way back in the day, and the mix catalogs themselves can be quite intensive. So that's what I was typing in the chat there is we don't have, oh, 3 mixes for 4,000 psi, 5 mixes for 5,000 psi. We have tens of thousands. In fact, when I was at Central Concrete, we had, over 20,000 mix designs, and we went through a huge multi-month effort to clean up that catalog, and we brought it down to like 15,000 mix designs, right? And then it's changing with materials on a regular basis. So if cement that's coming in is changing and all these other things. So the mix designs themselves, just even application for a similar mix code can change over time. So it's one of those things that's very difficult to actually just tag on a label and make it consistent, because some of these EPDs are generated, but then they're used over the course of many projects and those types of things. And so capturing an updated EPD at the same time as, other changes within it. So it just becomes very difficult. So I think we're all are advocating for it, but the infrastructure to support that, I think, is still in its infancy. So we have Climate Earth and those types of programs that will probably better help us manage that over time, but it's just not quite there yet. So as it becomes available, I think we will get to that point. But in the near time, I think we all need to be cognizant as designers to just be aware of the impacts of those types of things.
Yeah, and I definitely appreciate the complications or challenges and building up some of the infrastructure. And I think that's why we talk about it, right? Is to recognize those things and try to improve. One thing that just always comes to mind for me is just from the structural engineering perspective, we're always reviewing specific mix designs for specific applications. And a lot of that, I mean, sometimes it does end up in that kind of voluntary field, Mikaela, that you showed, and it feels doable, I think, is my spirit around it. Though obviously coming from the ready mix side, Brandon, you would
And I want to add
experience
one
that.
more thing. So this was another comment to several more disclosures that were requested during the PCR development process, was that states, cities, municipalities, authorities having jurisdiction are free to ask for that, right? And owners are free to ask for that, and anybody purchasing is free to ask for that. So one of the other arguments of the concrete producers was that, hey, that's between my client and I. They want to ask for it, they can ask for it, right? And we'll deliver it. So I'm not saying it can't be done. I'm just saying they're not a fan of mandating more requirements on themselves, if that makes sense, because they do, like Brandon said, have a lot going on.
What a great segue. I think that leads right into Francis's comment. And Francis, I'm not sure if you want to chime in, but the question then is, what do we do now in the next 5 years if the PCR will not be updated? And I think, unfortunately, I mean, it sounds like some of that onus is put back on individual. If it isn't done at the highest level as a mandated requirement, it is put back on local municipalities. Looks like, Francis, you said two of the Bay Area agencies you're working with two that are strongly recommending to start collecting application and volume. I don't know if there's anything you want to add to that, and we do have a question from Nathan too that I want to make sure we don't lose.
Yeah, sure. So in the initial data they were able to give us, I think we had to do something similar to Jonathan, where we were we had more than the EPDs. We were actually working off of what they were collecting in-house, and then, but it was missing like an application field. So we were trying to deduce that from a general description. Sometimes it was, description more about location, and then use some trends with the majority of times a mix was used, that mix number was used, then we inferred that that was the most common use for it, but saw that that wasn't always the case, right? That there were mixes that appeared to be used for multiple applications, but again, not having like a discrete field, and then we was making it, not as robust of analysis as we would have liked, and so they understood that a big part of like creating a program, a low carbon concrete program, would be about improving the data collection and adding that field and having it be like a discrete drop down. So I think that like some alignment across municipalities with or just agencies in general on what this drop down list is would also be useful for the larger. Now if we want to like actually raise all of this data collection up to a high level for academics like Jonathan to analyze and look at more widely. But at the same time, even just within the agency, it would be really helpful for actually establishing GWP limits or such. And yeah, actually, we also found that the application seemed to matter more than the current strength categories, largely because a lot of it was non-structural.
Yeah, thanks so much, Francis. Okay, I'm going to circle back to Nathan. Nate, you had a question here. Did the use of industry average cement data represent a ceiling limit for GWP values, e.g., were there examples of supplier-specific data with higher GWP values than the industry average values?
I hope that question is understandable. I guess what I'm asking is,
Yeah, feel free to add some context around it.
Is anybody in the concrete space using facility-specific cement data that's higher than the like PCA or ECA industry average values, or do folks that have cements higher than that just use industry average values instead?
That's a good question, Nathan. Thanks for the clarification. I think, and Mikaela could correct me because I know you were looking, Mikaela, at the distributions of bills of them. I believe there are some suppliers who use their supplier-specific data, even though it is higher. But we were kind of digging into that a little bit deeper out of this study. But it's not uniform. Like there are some manufacturing companies who use supplier-specific data for all their plants. Some that, don't do it for any of their plants. And then there's kind of this interesting in between where there are some manufacturing plants that use supplier specific data for some plants. Maybe that's just because it's already there. They already they can easily get it, or they use the industry average EPD. But again, and Mikaela, jump in if I'm mistaken, but I believe there are some EPDs that use supplier specific data, even though that seems like that cement's data might actually be, or GWP from that cement data might be higher than what's reported on the industry average EPD.
Yes, that's what the data illustrates, but I don't have specific examples of individual manufacturer names or anything like that. But I think that it is essentially both of what you're saying. More often, there are folks incentivized to just use the industry average if they have actual impact that they know of above it. But there are actually manufacturers that use supplier-specific data as well, even when it is above the industry average. So both occur.
Is that sort of, let's call it a loophole, kind of being tackled in the latest PCR as well? Because I think there's a question on the material side, and then there's a question on like the building side too. It's like if we're getting EPDs, like we should be required, right, to inform what we know in the building, and maybe some of that onus too should be like makes me think about initially EC3 was set up where it's like the baseline was an 80th percentile, and the incentive for that was to push you towards kind of using specific information, because if you didn't have it, you had to bump it up higher. So maybe that's a twofold question. It's like, is the PCR being the latest PCR being incentivizing more specific data, and what do you think we should do on the building level side too?
Another highly debated topic what Mikaela can discuss as well. But basically, we went back and forth on this and even had a vote through the committee. And we voted to not make it mandatory to have primary specific data for cements. But that being said, the PCR does give a hierarchy and says use primary data if available. So you must. So it's a mandatory language that you must if it's available. And then it'll go to default to industry average, and regionality is important. So it'll be a regional industry average, and then it will be national industry average. So best available data is the hierarchy. And once again, that's between the supplier and the buyer. So if the buyer wants specific, they can ask for it, whether that be an AHJ on policy side, or an owner, which some owners are going to ask for that, like Amazons and things like that are more savvy with EPDs. They're going to want to see more primary data. But yeah, so yes, but we will also have a note on the EPDs that says this EPD uses industry average cement data. So you will know it when you see it. So there's a kind of like, and that was our happy medium, correct? Because again, producers don't always want to give away who their cement supplier is. They feel like that's proprietary information and it's a competitive advantage for them, and they don't want all that out there.
But it is using, so that the hierarchy is use what you have if you have it, which is self-policed.
It
would
says
take
you
it,
must use primary data if available.
but that's enforced by the people developing it. Yeah. And then it's average, and it's not
And then,
like
yeah, and then it's going to go specific, average, best available. And that's not just for cement, it's for aggregates and all the constituent materials. We have the same hierarchy for each of them. So we're trying to incentivize good behavior, and in the PCR, it just gets really hard when you have so many, because we're very diverse stakeholder group on the PCR committee. It's not all producers. I mean, we have a nice balance. I'm talking 50-50 split between agency, environmental group, CLF, building transparency, and then producers and cement producers. So that was the happy medium. And cement producers were fine with putting that. I will say most of the US cement producers are already using specific data in their EPDs. I saw Karen's on here. I know Cal Portland does.
great. Okay. How about the Mikaela, Jonathan? I mean, what do you think about the flip side of that on the building level too, once you're getting these EPDs? I mean, my question is really like, should we, because right now it's relying on, like Tiffany, you're saying, people being knowledgeable and proactively asking for stuff like this. Whereas if it were set up like some of the precedents in like Europe and the UK, it's like, you're dinged if you don't have it, right? Rather than Nate's kind of, well, if you're higher, then you're sort of incentivized just to use the lower level, even if it is written in that you have to do it otherwise. Not that everyone doesn't do the right thing all the time, but
I think one interesting, I'll agree with Tiffany that we spent many hours on this very specific topic. And as always, there's a spectrum of possible outcomes, ones that could be more incentivizing of data and ones that are a little more but also could be viewed as harsh. And I think one interesting thing that hasn't been brought up so far has been the discussion of imported versus North American cements and the disparities of availability there, and that there are specific markets in the US that specifically import a lot, and the producers that are really protective of that problem, that they're the little guy. They have not that, as my understanding, they don't have very much influence. And so I found that an interesting argument. Again, I tend to err on the side of like, let's incentivize better data, but I also understand the market constraints that are out there. And I think that's an interesting one because there is mostly North American cement data available, but that is not the majority for imported cement. So with a lot of public policy coming on, I understand that the interaction and merger there of constraints for producers. So that's just an interesting topic. And then
Mikaela, I'll throw in there and add on to what you're saying real quick, not to interrupt you, but that was a trade thing, right? So free trade, and we can't treat domestic cements differently from imports. You have to treat them equally. That's a legal thing, right? So if we're going to require primary data for domestic cements, we need to do the same thing for imported cements. That's very hard to enforce. They have different ISO requirements, different PCRs, who knows what's going on. So it's very difficult to force an import to adhere to US standards. I don't know how Europe does it, but I think we'll probably move in that direction. Most will start asking for
Hey,
it, I believe.
sorry. I think we're kind of past time at this point. Sorry.
So we gotta wrap things up. All right, I close. I want to give huge thanks to Jonathan and Mikaela. Thanks so much for sharing and for everyone contributing. Very interesting discussion. I hope we can continue talking about this. It's an important topic, and I think it's great to take some of those discussions that have happened kind of in many PCR committee Zoom calls. I'm sure it's challenging, and kind of bring that out to a broader group so we all better understand the context. So onward to
thanks for having us.
the mountaintop.
Thanks, Luke. Thanks, guys.
Thanks for having.
Thanks, you guys. It's really good.
Okay,
Appreciate
take care. Bye.
Bye.